Today we're going to look at some trigonometry on the unit circle. So let's say I have a circle. This is the unit circle. And the radius is 1. And then I divide it up into 4 quartiles. And let's only look at quadrant 1. Okay. If I have a point right here, and remember our radius is 1, the point's coordinates will actually be cosine theta, comma, sine theta. And it's because of the properties of their ratios, because sine is opposite over hypotenuse, and the hypotenuse is just 1. So sine would just be this red line, and then same thing for cosine. It's adjacent over hypotenuse, but hypotenuse is 1, so it's just going to be this green line. Next, where's tangent? So tangent is a little bit more tricky to visualize. Let's say we draw a tangent line to this point, and it's going to go like this, and it's in yellow. Now this yellow line is actually tangent, and it crosses the x-axis, or it touches it. So this yellow line is actually tangent. Now why? So some people might know that tangent is actually equal to sine over cosine. Why is it? Why? The reason why tangent is equal to sine over cosine is because of similar triangles. Right. So this is our theta, as we know, just normal theta. Now, I drew this new triangle that you might not have realized. This yellow. So the purple and the orange triangle are actually similar. Why? Well, I'm going to draw it right here. That's theta. That's a 90-degree angle. And we don't really care about this other angle, but we know that that's 1. And this is sine. And this is cosine of theta. And then this orange one, I'll try it right now. That's a 90-degree angle right there. And then this is the same theta. And then, so if there's a 90-degree angle here, 90-degree angle here, and then these are both thetas, then this angle must be the same. Has to be. Because of properties of triangles. So if they're the same, then that means all 3 angles are the same. And that's triple angle similarity. So when you have similarity, what you can say is that you can create a ratio between corresponding parts of triangles. So, as we know, this is tangent of theta. Maybe we'll use another letter to describe it. Let's call it z, right? So, oh yeah, and we also know that, remember, our radius of the unit circle is 1, so that's going to be 1. So it's z over 1, right? That is kind of equal to the opposite over the adjacent right here, right? If we compare it to the angle. That's the opposite side, and that's the adjacent side, right? Opposite over adjacent. That's why tangent is equal to opposite over adjacent. But what is opposite over adjacent over here? Well, this is the opposite, and that's the adjacent. And that is sine over cosine right here. So that's actually why tangent is known as sine over cosine. Now that we know that tangent is equal to sine over cosine, there are also three other important trig ratios that you should know. We'll start off with cotangent. So cotangent, let's imagine I draw a line right here that's tangent to the point on the circle, and it hits the y-axis right here in white. Now we're going to call this z again, and let's notice that we created another triangle, just like how we did with tangent. This overall big triangle, I showed in red, right here. That's our height, this is our hypotenuse, and that's our base, right? So we can create that. I'll draw it right here. That's z, and then what is our base? 1, right here, the radius. Now where's theta? Oh yeah, and this is 90-degree angle right there. Now where's theta? So we know theta is right here, and using interior angles, we know theta is also right here. And then we use some more geometry, and we know that theta is right here. Okay, so that means theta is right here. So the triangle will look a little bit more funky, but it's okay. We still work with that. So now what? We should relate this to our original triangle in purple, so we can figure out what z is. I mean, we already know it's cotangent, but I mean, what is it, right? So I'll draw it right here. 90-degree angle, right there. Theta, 1, and this is cosine, and that is sine. Now, what is z? So when we look at it according to theta, we see that z over 1, it kind of looks like the base over the height, right? If we kind of like shift our perspective a little bit, like we look at it kind of like this, and this is theta, right? That's z, and that's 1. Z over 1 is like the base over the height. Where can we see that as well? Well, if we look at it here with theta, the base over the height, well, that's just cosine over sine, right? Wait a minute. Cosine over sine, that looks exactly like sine over cosine, but flipped. That's why it's cotangent and tangent. It's complementary tangent. So now we know cotangent is actually just cosine over sine. And we used similar triangles again. Now, what are cosecant and secant? Let's go back to this bottom part of our quadrant and look at this length in green, right? We don't know what length this is. Actually, using similar triangles, we can figure it out. We use that big orange triangle as we were using before. We use the same similar triangles as well, right? That's theta. And then we use the purple one that we always relate back to, remember? So we have theta right here, 90-degree angle right there. These two triangles are similar. That's 1, and this is also 1 right there. This is tangent. This is sine, and that's cosine. So what can we do now? Well, let's call the green thing, let's call it z again. Let's just keep calling it z. So z, alright. So we always try to put something, our unknown thing, over 1, and then we can relate it back to our purple triangle. So z over 1, that is kind of like the hypotenuse over the base. Do you see that? It's the base because it's the adjacent. It's the side that's closest to the theta, not opposite. It's adjacent. So it's actually the hypotenuse over adjacent. Does that sound like anything we know already? Well, we actually know what adjacent over hypotenuse is. That's cosine. So that means secant, which is equal to z, right? It's actually just the hypotenuse over the adjacent. Now, where can we find that on the purple triangle? This is the hypotenuse, and that is the adjacent. So, secant is equal to 1 over cosine. Boom. Done. So 1 over cosine is equal to secant. That's the reciprocal identity. So when we're looking for cosecant, it's actually very similar to secant. And you might notice that there's a co in front of it, in front of the name. Let's use this green again. So this length is actually cosecant theta. What is cosecant? Remember, we use similar triangles to find out. So we use this big red triangle, and we always relate it to our purple one. So that's a 90-degree angle because this is a 90-degree angle. And where's theta again? Remember, theta is actually right here and right here. Or no, not right there. And right here. So that means theta is right here. Where's 1? 1 is our base. I mean, it looks like our base, but according to theta, it's actually the opposite, or the height. And cosecant is our unknown. We'll call it z. Right there. Now, what is z in terms of theta? So in terms of theta, right, the 1, it looks like the base right now, but if you like shift your head a little bit, it actually is the height, or the opposite angle, right? This is the opposite angle across from it. So it's actually the height over the hypotenuse. What else do we know is like a height over hypotenuse? Remember, relate it back to our purple one, purple triangle. Height, 1, and our hypotenuse, or no, our height, that's sine, right? Because this is cosine. So that means z is equal to 1 over sine. So that is the last reciprocal identity. That I'll be talking about today. Now, you can see through all these triangles that I just created, right? And we figured out a lot of these new trig ratios. We figured out that this is cosecant. We figured out where cotangent is, cosine, sine, tangent. Oh yeah, here's secant. Pythagorean identities. Now there are 3. And if you can spot them, you should pause right now before I show you. Sine squared plus cosine squared is equal to 1, right? Because of our purple triangle. I'll show you another. 1 plus tangent theta, tangent squared, is equal to secant squared. And here's another. 1 plus cotangent squared is equal to cosecant squared. This is like the holy grail, okay? These are like the #1 things that you use to prove trig identities, and it's gonna save your life. Just if you had to know just one of these, definitely remember this one: the sine square plus cosine square is equal to 1, because this shows up everywhere. Okay, thanks for watching.